course of Bioinspired Control with the teacher Dr. Martin Montes. For these six controls, we need to control to a DC motor. Why? Because my project is the control of a blood centrifugate, and a blood centrifugate is a device or a machine that used in the hospital to separate the different substances in the blood. And in this part, I use the Fuse controller, the Mamdani, Takashi Sugeno, proportional derivative, and integrative, and FS. With the six control, I obtain different behavioral in the graphics of the stability. For a start with this project, first we need to obtain the transfer function of the DC motor, and for this I use this document for determining the parameters of the DC motor, and with this we can obtain the mathematical model of this. This is all steps for obtaining the transfer function, and different part we need to use the scope, obtain the different parameters, and in the final we obtain the transfer function. This is the example, but in my case the motor that I use in this part is this. My transfer function? For this video I start with the Mamdani Fuse control blood centrifugate DC motor position. In this part we have the libraries, the control, the OS, NumPy, Matplotlib, IPython, TikTok, Vido for the 3D model. In this part import EP1 because in this part we use the library of the Dr. Martin Montes. The name of this library is UPA Fuse system, and with this library we can import the Fuse universe, inference system, and Fuse control. This for obtain a good control and a good programmer with Fuse control. After this we have a function for a data block or diagram block in this case. After this we have the step information of the reference, and in this part we have the instruction for name each block in the block diagram. After this we have the parameters of the DC control. In this part is the information of my transfer function, and in this part we can see the correct transfer function, the numerator and the denominator. After this we have the input. In this part we have 207 because in my case I have three linguistic variables, and in the control of my block centrifugate, mega centrifugate, micro centrifugate, and ultra centrifugate. With these three I try with three different grades in the motor. In this part we have 200 because 200 the 3D model Well, in this part that I mentioned, we have three linguistic variables. Sorry. Well, for this, if the input is to approximately 270 or something like that, we have a movement of the motor, and the motor ascending and descending the velocity, and in this part we have the control for the sedimentation of the flood. In this case, sorry, I have to approximately 200, but we can use also 45 and 25 for the two other linguistic variables. Yes. Well, this is the part. In this part we have the time and the number of the saplings or muestreo, and after this we have the system rules for the Mamdani, the size of the universe, that the input and output universe. This is the part, this is the other part. This is the response, the surface response of Mamdani. The TikTok for obtain the transfer function, and apply the fusing control. In this part, we have the TikTok for the output, the response, the results, the max, the minimum, the overshoot that can obtain in the graphic, and this is the block diagram. After this, we have the program of the 3D simulation of the motor. In this case, in the motor, we add another element for simulate the blood centrifugate that we can see in the hospital or something like that. Yes. Well, in this part, we restart the kernel, and we can see the behavior of this part. Well, so only we need to wait for the control, and only we need to wait. And in this part, we can see the motor, and move, move, move. And approximately in 15, we have the response in 200. Only we need to wait. $75 around. Well, yes. In 70 we have the correct, or well, approximately the 270. This is the response, the block diagram. And after this we have the Takashi Sugeno response is this, and the stability is approximately the same time of the bus controller, and the part of this is the same. We have the libraries, the function for the block diagram, the parameters, the transfer function, the input, the inference rule for the FLA control. We have this surface, this response, the universe for the input and the output. We have the TikTok for the transfer function, sorry. And these the parameters, the final parameters, the graphic, the block diagram, and the 3D simulation of the motor. In this case, well, the model of the blood centrifuge, right? Well, with this we have this part, and restart the kernel for see the response in this part. This control is the Takashi Sugeno, and we need to wait. It's the same case of the Mamdani, and this is more quickly, and well, this is the response. Is more faster than the Mamdani, but the time is approximately the same of the Mamdani. Only we need to wait. This is the response. It's approximately the 217, and well, in approximately 50 seconds in the time. Well, and this is the response. This is the all, and we can see in others angles the design, the motor, the dish, and the glasses for the blood. Well, after this we have the FS BUC control. We have the same part, the libraries, the function, the parameters, the input, the input, sorry, the inference system in this part. We have the this part for the TikTok for the transfer function, the response, the output, the final parameters, the graphic, the block diagram, and the 3D model of the motor. This part is the same, and only put restart the kernel, and this part is more faster than the Mamdani. And we have the same case. We need to wait for the restart of the kernel. This is the surface of the response. And wait. Without overshoot, and the response. In this part, I need to increase the time because with less time I don't have control. And we need to increase this part. Is more or less than the Mamdani and the Takashi Sugeno. The FS PC control is really less, and this is the response. These three controls, is for the FS, TS, and Mamdani. After this, we have the PID PUC control, and with this, we can see a big change in this part because the time for this is really short. It's around 3, and it's a big difference between this control to the PID PUC control. We see the PID control. We have the same parts: the library, block diagram, the moving average, the input, the parameters, the block diagram, the input of the control, the system rules. Have this, but in this part, we have the surface linear 1 input. In this part is this, but in this we need to add the different control variables for the PID. In this case is GA, GU, GU, GCE, and GCIE. This is the synchronization method for this part. And well, we have the same, the feedback for the output, the parameters of the final parameter, the block diagram, and the 3D this part. For this and for the video is not a lot of long. This part I comment yes, and put this the restart kernel, and we need to wait. Wait. Well, in this part, proportional derivative integrate, this is the control. Is more faster with a short time, and we can see this behavioral in this part. We have. And is more precise and exactly of the others controls, because in the other controls we obtain a 269, and with this we obtain the exactly variable, the exactly value, and it is the result. In 5, the value of the time, we obtain the exactly value. Yes, this is the result. And this is the same design. The same design. Yes. Is this. Well, close this and save. After this, we have the proportional derivative. We have the same part, the same. And this, well, this is the same. This I comment and restart kernel. And we only need to wait in this part for this run, and we see the result. Well, here is the response. Blood centrifuge is really fast. Yes. And this part descend the velocity, but for my project it's good. It's not a big problem. And it's good for the application. Only we need to wait. Wait. We need to have 5 in the time, and in 5 we have the exactly value that we need. Yes, it is. And well, we need to close this part. Close. And for the finally, we have the proportional. Only the proportional. We have the same part, the same rules, the same transfer function. The gains in this part will change, equal to the for the PD and PDA. The values change. This is the part, and for this we need to restart kernel for see the final result. Only we need to wait. Yes. This is the final result. In this part we need to arrive to 5 in the time. Well, this is my 6th FUC controller, and well, my project, my transfer function, and well, this is all. Thank you.